Welcome, guys. So, time to, get through the recently passed VCAA NHT exams, and hopefully this will be useful for your preparation for the end of year exam in this November. I need to make this disclaimer first. VCAA holds all copyrights to the exam materials, and this suggested solution and the power slide is not intended to be an exemplary, and it is not endorsed by VCAA. So teachers and students who are watching this video are strongly advised to refer to the official VCAA assessment reports. Right, and make sure you read the instructions carefully and answer all questions in the space provided. Try not to go beyond the boxes, etc. And in questions where a numerical answer is required, an exact value must be given unless otherwise specified. That means fractions, thirds, or pi, e, etc., etc. In questions where more than one mark is available, appropriate working must be shown. So if you just got the correct answer, but with some incorrect methodology in front of the correct answer, it could penalize you, all right? So avoid over-engagement before or after. Unless otherwise indicated, the diagrams in this book are not drawn to scale. That means you can't use a ruler to measure something or use a protractor. Yeah, you are not allowed to bring a protractor in exam 1. Anyway, let's get started. If y equals sine x squared plus 1, find dy dx. Basically, this is just simply a chain rule. So derivative of the inside times derivative of the outside. Sine has derivative cos, and u is x squared plus 1. The derivative of that is 2x. Multiply them together, you get 2x times cos x squared plus 1. All right. And the next one, I accidentally put the answer here, but the intention was you need to use your product rule to find the derivative of this guy here. But don't just stop here. You have to substitute x equals e. Basically, you just get 2x times log ex plus x squared times derivative of that, which is 1 over x. So subbing in x equals e will get you to 2e log e plus e. Notice that this term is 1. So your answer should be fully simplified, 3e. This is a very simple question, simple math. So make sure your answer is simplified. All right. Next question, very easy integration question. Find f of x. Given that f0 is 3 and f dash of x is 2 over x plus 1 plus 2 cos x, where x is greater than minus 1. The reason why the setting panel, I suppose, include the condition here is because they don't want you to put an absolute value once you integrate this term. Yep, specialist math student would be expected to put log e absolute x plus 1 something, but in math method, it's not part of the math method course. So you just need to consider this one as a positive quantity and integrate, put it in a normal bracket. The very first step, integrating to get the antiderivatives plus c. You need the plus c here. If you don't put plus c here, your remaining working will be invalidated. Now, integrating and substituting. Sub in x equals 0 and y equals 3. In this case, f is 3 to get your c value. Notice that once you substitute x equals 0, you will get 2 log e1 and 2 sine 0. Both terms are zeros, so the c value is simply 3. Many students are up until this point will be like, oh, hooray, very easy. Okay, no. You need to state your f of x, okay? Examiners, they will be hammering incomplete answers. So you have to state your rule of f of x, 2 log e x plus 1 plus 2 sine x plus 3, okay? Of course, there will be some advanced technologies or advanced techniques. For example, using the definite integral to solve the first order differential equation. But when you apply this method, make sure you use dt instead of dx. You can't repeat the letter here, all right? It must be du or dt something first. Then you integrate with respect to your another letter to get something like that. Don't forget to add the initial value of f, which is +3, and evaluate this definite integral, subbing in x and 0 to get your f of x equals these sort of stuff, all right? Now, a marketing company wants to estimate the proportion of a population who regularly ride bicycles for exercise. The company randomly samples 100 people from this population and finds that 10 of these people regularly ride bicycles for exercise. So using v equals 2, this is a clear instruction. And 100 people, that's n value, 10, that's your x value. And you want to find an approximate 95% confidence interval for the true proportion of the population. It's not the confidence interval for sample proportion. It must be the confidence interval for population proportion, okay? Basically, you just need to quote the formula from your VCAA formula sheet. And notice that this is p hat, not p. And this term is not to be confused with the term standard deviation of sample proportion. This is called standard error, all right? Standard error, because you use the p hat instead of p to calculate this sort of standard deviation, but it's not a standard deviation. Basically, you're chucking the values 10 over 100, which gives you 1 over 10. So 1 minus p hat will be 9 over 10. Now, I suggest you calculate the standard error outside the bracket separately. Calculating fractions under a surd, you need to be careful. 9 over 10 times 10, which is 9 over 100, divided by another 100, which gets you 10,000 at the bottom, all right? So taking the square root of that, you recognize this is 3 over 100. Now, if you calculate it one side, you don't need to repeat the calculation on another side because this term is exactly the same as this term, all right? They're just adding and subtracting the same amount, okay? 2 lots of the standard error using z equals 2. Many students will confuse on when to use 1.96, when to use z equals 2. Well, read the question. If the question wants you to use z equals 1.96, the question will be explicitly making the instructions or giving you something like corrected 2 decimal places sort of instructions. So you will get the answer 0.04, 0.16. If you wish, you could write it as fractions. Remember, it's an open bracket, okay? Open bracket here and open bracket here. But in terms of confidence intervals, I prefer the answers to be in decimal form, all right? Because fractions tends to be exact answers, whereas this is an approximate confidence interval, which will be better represented by decimal values, okay? So that's your question 3. Now let's look at question 4. 7 marks, a lot. It has multiple parts. Consider the function f from 0 to 2 pi. F of x is a sine x plus b, given that f of half pi equals 2, and that f of 3 pi on 2 is -8. So you want to show that a equals 5 and b equals -3, because the answer is in front of you. What matters is your sequence of derivations or steps. So you substitute the first pair of values to get this equation. Notice that sine half pi is 1. So a times 1 plus b equals 2. This is your first equation. And it is also necessary for you to write down another equation. Notice that sine 3 pi over 2 is -1. You must know your exact values very confidently when you walk into the exam rooms, okay? With these 2 equations, you notice there is an a and a -a. So adding up these two equations will give you, let's say, 2b equals -6, which gives you b equals -3. But here I used another method. I subtract the second one from the first one to get a equals 5, which is also true. So from these two equations, you need to show some correct working. And yeah, that's basically the show that question. And let's look at next one. Sketch the graph of y equals f of x on the set of axes below. Label the endpoints and the turning points with their coordinates. So you should have some graph like this. Notice that -3 from previous part is your equilibrium position, and the amplitude is 5. So from -3 add 5, you will get a maximum value 2. From -3 you subtract 5, you will get -8 as the lowest y value. The question explicitly asked for the coordinates for these 4 points. Even though the question didn't ask for these coordinates, you still need to make sure your graph goes through these points. It's something like a point of symmetry, okay? Also known as a point of inflection. These 3 points must stay on the same line, y equals -3, sorry. All right, so hopefully you guys get the idea of sketching the sine curve, which is very basic from year 11 level. So let's look at the next one. State the values of k for which the equation f of x plus k equals 0, where k is a real number, has no solution for x, which means if you see this one as a combined graph, f of x translated either upwards or downwards. This translated graph must not touch or cross the x-axis. So I will interpret this question from a graphical point of view. So let's have a look. Let's say if you translate the graph just by 2 units downwards, okay, then you will see there is a touching point here. But your target is for the graph to not touch the x-axis. So your k value, because it's a downwards translation, it must be less than 2, -2, okay? On the other hand, the other direction, if you translate the whole graph by 8 units upwards, so you will get k greater than 8, because your target, again, is for the graph to not touch the x-axis, okay? So it must be higher or lower. That's why your overall k value, k set, must be -∞ to -2 open bracket, union, open 8 to infinity. Make sure you use union here, not intersecting, okay? This is another story, but you have to make sure your notations are consistent and correct throughout the paper. All right, let's have a look at the next one. Find the value of m for which 0 to pi f of x plus m dx equals 0. M is a real number. So it's just calculate the definite integral as it is. You just chuck in your f of x explicitly, 5 sine x minus 3 plus m dx equals 0. Remember, the antiderivative of sine is negative cos. Many students confuse the derivatives and antiderivatives of sine or cos terms. So read your formula sheet. And in this case, I treat m minus 3 as a constant. So I just multiplied an x after m minus 3, putting 0 pi next to it in a square bracket. Equate the whole thing to 0, and you plug in the x equals pi into the function, subtract x equals 0, it's plugged into the 2 terms. You need, again, to know your exact values. Cos pi is -1. That's why your first term is 5. M minus 3 pi, and minus becomes a plus. Cos 0 is 1. So you end up with 5 here. This is very important, anti-differentiating and evaluating the cost terms accordingly. And you will end up with m minus 3 pi equals minus 10. So m minus 3 equals minus 10 over pi. Therefore, m is 3 minus 10 over pi. Alternatively, if you want to combine these two terms, you can write it as 3 pi minus 10 over pi. But try not to make any mistake if you want to over-engage. I think this one should be sufficient. All right, it's a correct answer. These two are equivalent forms. All right, so that's question 4, part D. Okay, now let's look at the next part. Question 5. Indices and logarithmic laws. Consider the function with rule f of x equals e1 minus x as the power. Simplify f of x over f minus x. Express your answer in the form ekx, where k is an integer. That means your answer must be e minus 2x, exactly in this form, okay? So you just plug in e1 minus x and e1 plus x. Negative canceled with negative, okay? And you're subtracting the indices, okay? Make sure you put a bracket here. That's a common place for students to make mistake, I suppose. Show that f of a times f of b equals f of a plus b minus 1. Either side are not very simple expressions. So you need to show both sides of works, okay? F of a times f of b, evaluate that from the left-hand side. You will end up with e2 minus a minus b. Just add up these two indices, okay? Now, it's not enough to just assert it equals right-hand side. You have to also show from right-hand side by substituting a plus b minus 1 into the whole expression. You need some clear substitution. So f a plus b minus 1 give you e1 minus a plus b minus 1. And it is important to put a bracket here, okay? Now, this also evaluates to 2 minus a minus b equals left-hand side. So showing both sides work in this show that question is critical, okay? Very crucial. Right, let's have a look at the last part. The last part is an equation solving. So you equate your f of x to 2, and you must give your answer in the form x equals log e m over m. Basically, you just equate e1 minus x to 2. And this term will be further written as e over e to the power x equals 2. Basically, you can just swap this term, this ex term with 2, swapping their positions, and the equation still holds true, okay? Unless this one is 0, you can't do that. E to the power of x is half e. So take log both sides with base e. You will get x equals log e half e in a bracket. And put a bracket here. Try not to write something like log. That will be very ugly. Question 6, a typical tree diagram question. Well, I spoiled the fun, but that's the way you do the question. In a particular city, the probability that it will snow on Monday is x squared. If it does snow on Monday, the probability that it will snow on Tuesday is a quarter x. If it does not snow on Monday, the probability that it will snow on Tuesday is x. So we want to find an expression in terms of x that gives the probability that it will snow on both Monday and Tuesday. Snow, snow. Let's have a look at this tree diagram. Snow, snow. Given snow, snow on Tuesday. X squared times a quarter x. So it's just x cubed over 4. Easy. Find the value of x if there is a 25% chance that it will snow on both Monday and Tuesday. In my own opinion, I advise against writing the probabilities as percentage, but the percentage is given in the question. You have to use the correct fraction form, which is 1 over 4 or 0.25. Basically, you just equate what you get from part 1 with 1 over 4, 25%. And the only answer is x equals 1. So very straightforward question. Now, you need to find an expression in terms of x that gives the probability that it will snow on Tuesday. The implied message is regardless of whether is from your tree diagram, whether it's snowing on Monday or not. So you need to consider x squared times 3/4 x. Add 1 minus x squared times x and simplify that expression. Bear with my poor formatting here. The answer should be x minus 3x cubed over 4. Okay. The writing lines covered my vinculums and the subtractions, but I hope you guys can get it. Find the value of x that will result in the highest probability that it will snow on Tuesday. Okay, it's referring to this probability from previous part, and find the probability itself for this value of x in the form a over b. A, b are integers. So to get the highest something, it's all about optimization problems, which means you can let your probability be y and take dy dx equate to 0. This is to find your potential maximum or minimum turning points. Now, equating that derivative to 0 will give you 9x squared equals 4. So x squared is 4 over 9. But remember, x implies a probability. It must be a positive value or 0 or not exceeding 1. So simply speaking, your only possible x value is 2 over 3. And if you look at some sort of graph, this graph, I suppose it's a cubic graph. It looks like that. So you do expect some highest point in the middle there, all right? Anyway, let me get rid of the annotation. Right, so the next job is to substitute x equals 2 over 3 into this expression. Notice that it's 2 over 3 subtract 3 over 4 times 2 over 3 cubed. And it will be 8 over 27, but you will notice 8 will cancel the 4 here. So you end up with the 2. Therefore, your answer should be 2 over 3 subtracting 3 times 2 is 6 and over 27. So it's 6 over 9 minus 2 over 9, which gives you 4 over 9. And that is your highest probability itself. This question was a 3-mark question. So you need to show some methodology, attempt to differentiate or equate to 0. And I think it's commonly known. The x value, that's one object required by the question, and another one, and find the probability, the correct probability. Okay, so make sure you address the question to receive the highest mark possible. Right, question 7. In my opinion, and some of my friends or teacher friends or colleagues also highly commended this question, very creative. The question embeds the inverse function and polynomials. They were drawn together, these two ideas. Let's look at the question. Your p of x starts from 1 to infinity, and it's quartic function. You want to find the value of a when p minus 1, p inverse a equals 2, where a is a real number. The idea is on the graph of p inverse, the point is reads as a comma 2, but it's an inverse function. So you trace back to your original function by swapping x and y. Therefore, on the original function, it's 2 comma a. So x equals 2, y equals a. So the idea is to substitute x equals 2 into your original function instead of finding the inverse function itself. Okay, if you try to find the inverse, that will be very hard to do because it's very hard for us to find the inverse for cubic. if the cubic is not in turning point form or even in quartic, okay? So make sure you use some clever method. Notice the basic property, all right? Next job is just evaluation. So your answer should be 7. You can't miss it. You won't miss it. Now, the next part, find the value of b when p of b equals 1, where b is positive real number. So just write it as it is, subbing x equals b into the function to get this equation. Now, if you notice there are 2 1s on both sides, cancel them. The left-hand side becomes untidier, but you still need to take some common factors first. So b out, you will end up with b cubed minus b squared minus b plus 1 equals 0. Then we will use some sort of strategy like a factorization by grouping. Notice that for these two terms, b cubed minus b squared, you take out the b squared, end up with b minus 1. With minus b plus 1, if you take out minus 1, you will end up with minus bracket b minus 1. So b minus 1 by grouping is another common factor. Therefore, it will be b times b squared minus 1 times b minus 1 equals 0. I think this one can be further factorized into b plus 1, b minus 1, which gives you b plus 1, b minus 1 squared equals 0. Therefore, you will have 3 potential b values, 0, -1, and 1 from 3 factors by Nauer factor law. But the condition explicitly states b is positive, so you only have b equals 1. Make sure you reject the inappropriate solution from your working, okay? Now, part B is totally irrelevant. It's an individual part compared to part A. You want to find the rule and the domain of F inverse, the inverse of F. If F is a hyperbola like that, well, how could I tell it's a hyperbola? If you have a linear divided by linear and the 2 linear functions are not the same, you can use some proper fraction strategy to find the standard rectangular hyperbola form. And notice this x is not equal to 2. Therefore, the hyperbola is on its maximal domain, which contains its which results in the maximal possible range. We will talk about that immediately. So to find the inverse function, you always let x equals f of y. You need to mention, okay, this is for finding the inverse. Now, with x equals y plus 3 over y minus 2, you will end up with something like that. That's the strategy I was talking about. You see the top is y plus 3, so you make a minus 2 there and a plus 5 to compensate the minus 2. Now, y minus 2 over y minus 2 is 1, 5 over y minus 2. Leave it as it is. So, the next step is to subtract 1 from both sides. X minus 1 equals 5 over y minus 2. Therefore, you can swap x and y, x minus 1 and y minus 2. Swapping these two objects, you will still get y minus 2 equals 5 over x minus 1. Okay, I know to some of you that's a little bit junk, but that's a common strategy to solve these type of similar equations. Okay, because your target is to isolate y, all right, to transpose for y. So your y is equal to f inverse of x, because the question is looking for f inverse. You have to write f minus 1 bracket x, okay, not just y. And this whole thing is your rule, because you can add 2 to both sides. 5 over x minus 1 plus 2. Well, if you are up to this point, you are not fully answering the question. You still need the domain of f inverse. As I just said before, for this hyperbola, the maximal domain is x is all real number excluding 2. So the range is all real number excluding the value of horizontal asymptote 1. Therefore, the domain of f inverse is also real number / curly bracket 1. Okay. If you wish, you can write both things in one line, the functional notation, but it's not necessary here unless the question explicitly want to use functional notation. You can also state x is an element of real number \1 separately. All right. Okay, now part B finished. Let's have a look at our last one, the big boss. 8 questions. Last one must be some sort of hard question with multiple parts. So let's look at a graph. Part of the graph of the function f, where f is negative infinity to 0. That's the domain, including 0. Yeah. F of x is the product of exponential and a sine function, ex times sine x. Is shown below. Well, a nice function showing some damping pattern, but what will be explicit last? Let's have a look. Find a general solution to f of x equals 0. So you just equate ex sine x to 0, but you have to mention e of x is greater than 0 or not equal to 0. Okay, now the only thing remains sine x equals 0. Now you can say, okay, sine 0 is 0. That's just one solution. General solution means, okay, you have to list all possible values. For example, look back at the graph. This is the first one, 0. Yep, 0 is included. Well, minus pi, I suppose, because sine minus pi is 0, minus 2 pi, minus 3 pi, minus 4 pi. So f is k pi. K is a negative integer, also including 0. Of course, if you write, let's say, k minus 1 pi, or let's say k plus 1 pi, you need to adjust your k domain accordingly, okay? But here, I think the easiest way for me to write is x equals k pi. K is negative integer, also including 0, okay? Now, the next target is to find the general solution to f dash of x equals 0. So think about f dash of x, the meaning, and a 0 gradient. What does that represent? That gives you, from the graph, the possible turning points on the left branch, or just on the left branch, okay, of this graph. So, derive this function using product rule. Is x times sine x plus ex times cos x. When this is equated to 0, take out the common factor ex. Ex is greater than 0, it can be 0. So the sine x must be negative cos x, such that derivative is 0. To solve an equation with sine or both cosine on both sides, you need to divide both sides by cos of x. So sine x divided by cos of x is negative 1. This will give you tangent x equals negative 1. Think about tangent something equals 1. That's a quarter pi, but it's a minus 1 there. So you start with minus pi over 4. And you can confirm a rough position. Yep, minus pi over 4 is here. And how about this one? Well, you need to think about the periodicity of tangent function. The period of tangent is pi, okay? Tangent x. So you subtract another pi from minus pi over 4, subtract 2 pi from minus pi over 4, etc., etc. So your starting point, the reference angle is minus pi over 4 plus k pi, or you can say minus k pi. But if you write minus k pi, that means your k must be z union 0 instead of z minus union 0, z plus, okay? In this case, I just add k pi. K is negative, including 0, because you still need to cover the first point in the whole expression. And next, show that the derivative of ex sine x minus ex cos x is 2ex sine x. Well, some of you may be learning Unimath at the same time, but the question doesn't need you to do integration by parts. Just follow the instruction. Use product rule twice. Well, in previous part, you already derived this term and put a minus here. Make sure you put a parenthesis here, bracket, and use product rule again. EX derived EX times cos X, that's U dash V, minus, that comes from cos derivative becomes minus sign. In fact, initially there was a plus here, but I just merged the minus with the plus, okay? So you will cancel these two EX cos X term, and you will get a 2EX sin X. That equals to your right-hand side, okay? Okay, a typically integration by recognition question. Hence, find the area bounded by the graph of the function f and the horizontal axis over the interval. X goes from -pi to 0. Always trace back to look at a graph. See, 0 to -pi. This area is below the x-axis. You have to put an extra minus in front of the integral to cancel the negative and get this one, the magnitude of the area. Well, negative pi to 0, EX sin X. Why was it EX sin X? It's f of x, okay? And remember, your derivative is 2 lots of EX sin X. So if you want to apply back this backwards engineering from the derivative equation, you have to put a half in front of the derivative, okay, to match the EX sin X. And there is a small detail, a small move I did here. Do you notice the minus here? -pi to 0. But now I swap the order. If I get rid of the negative, I have to swap the order of the terminals, the limits, okay? Reverse the order. Now with the integration sign and the ddx, you undo each other to get half, don't forget half, EX sin X minus EX cos X, 0 to -pi. And I just substitute all the values, -pi into the antiderivative, 0 into the antiderivative, set it up nicely, like what I typed here, okay? Put a bracket, and notice these special values. I also wrote them down. Sin -pi is 0, cos -pi is -1, sin 0 is 0, cos 0 is -1. But don't omit these E terms, okay? So you end up with half E minus pi minus half -1. You end up with half E minus pi plus 1 square units. Well, this question also has some other equivalent form. For example, that if you write E minus pi like a 1 over E pi plus 1, then you can combine these two terms together and multiply the 2 into the denominator, which gives you this answer. But be careful with some over engagement. If you do something wrong in the process of simplifying, you could lose your answer mark, okay? Last time, ice on top of the cake. Consider the function. Well, look at this one. This function is -2 e pi over 1 plus e pi times EX sin X. So what happened to this function compared to the previous one, f of x? With the negative here, I suppose it's reflected. With this term here, what does that do? If you compare this answer with this answer, they are reciprocal of each other. So originally, the area on the f from 0 to -pi is the negative area, signed area. So we have to reflect the whole graph upside down, reflect the graph about the x-axis, and have some sort of dilation factor to make the area 1 from -pi to 0, such that it's a probability density function. Well, some smart student would say, oh, the answer is already contained here. how couldn't we just write down the reciprocal of this answer here? Well, you must be very careful. This question has a commanding term here. Hence, if your answer does not come from correct working, indicated by hence using this part, then you will receive 0 mark. Okay, so don't be too smart. Work very hard and follow the instructions. Maximum value. Okay, xm is the value of x for which g has a maximum value. Find probability x less than small xm. Okay, now I talked about a reflection and some sort of dilation, as indicated by this constant here. You might wonder, oh, why did you put a inverted graph here? Because I want to emphasize, okay, if it's reflected, originally x equals minus pi over 4 gives you a lowest value, but if it's reflected, it will give you a highest turning point. Okay, so far the maximum value. So that's my hint. That's my explanation. Link the reflected graph back to your part A2, which tells you the position of the first turning point. Now, it's all clear. We want to find x less than minus pi over 4. And if you notice, you have a 2 here. How convenient. Just multiply the 2 together with ex sine x. Then you can use your part. You can use your part C2, okay? Now, I take out minus e pi over 1 plus e pi and leave the 2 inside the integral. I know the lower bound must not exceed minus pi. So from negative pi minus pi to minus pi over 4. Anti-deriving that, oh, it's exactly 2ex sine x. So I can use the relation I just derived. I've just shown. So the antiderivative must be ex sine x minus cos x. If you look at the previous part, I think it's part C1, not part C2. This part, okay? And this is the correct formulation of your correct calculation of your integral using your answer from C1. And then you just throw in the values. It's all about calculating the exact values with correct transcriptions, okay? Don't be afraid to chuck in the values. Don't be terrified by the ugly values. They will all become a simple and nice answers, okay? Now, keep your coefficient as it is and throw in the values. The upper limit is minus pi over 4. So e minus pi over 4. Sine minus pi over 4 is minus 1 on root 2. And cos minus pi over 4, that's 1 over root 2, but with a minus in the front, okay? If you are unsure, draw a unit circle or some triangles to determine the quotients and positive or negatives. Minus pi. Sine minus pi is 0, cos minus pi is minus 1, but notice the minus here, put a bracket. You can see in my working, I regularly use brackets. Don't be afraid to use brackets. It will help you reduce the potential to make errors. Now, these two terms, you will be confused, some of you. Why is that minus root 2? Because it's minus 2 over root 2 gives you minus root 2, okay? And this bit will be minus e minus pi. So with the minus here, take them out to cancel with the minus. You will get e pi over 1 plus e pi times that bit. And yes, you can simplify this one by multiplying e pi into the bracket to get root 2 e 3 pi over 4 plus e pi times e minus pi. This is 1. I think a relatively elegant answer should be written in this way, but there could be other equivalent forms, I must admit. I did not include all of them here. So that's the answer to the last part. Okay. Overall, a very pleasant paper to work with. in my opinion. And hopefully you guys can listen to some useful idea to your own preparation in this video. Thank you for watching my video, and I will see you next time in the Math Method Exam 2 or an NHT paper this year. Bye-bye.